Hello everyone, my name is Yuxiang Guo and my teammates are Yingnuo Yang and Yang Yun Li. Our project is detection of vehicles in videos, which has become a widely discussed topic in the area of machine learning. Our raw data comes from GTI vehicle image database. We have two fields of training data, non-vehicle and vehicle, which contain more than 3,000 64 x 64 pixels non-vehicle and vehicle pictures respectively. We use three approaches to do classification. Support vector machine SVM with histogram of gradient HOG features, nearest neighbors with HOG features, and you only look once YOLO as a classifier to train data. Next, we will introduce implementation of three approaches in detail. This is our report. The first one is HOG plus SVM. In the first method, we first need to extract the HOG feature of training data. The reason why we use HOG is to simplify the image by extracting useful information, the gradient or the edge of the picture, and throw away some not useful information, and transfer the size from width times height times 3 image into length of 3,780 feature vectors. We use built-in function HOG function from OpenCV library to extract the HOG features. Here is our HOG diagram of the vehicle and the non-vehicle. Then we choose SVM to classify vehicle and non-vehicle. The objective of the support vector machine algorithm is to find the hyperplane in an n-dimensional space that distinctly classifies the data points, which also maximizes the margin distance for future prediction. The next one is KNN. KNN is very similar to the first one. After extract the HOG features, we use KNN as a classifier. The fundamental algorithm is to find the k nearest neighbors of testing sample in training samples and determine the class of testing sample based on the most frequent class in k nearest neighbors of the testing sample. This is the picture. When k is equal to 3, there are 2 triangles and 1 square, so the green circle is likely to be the triangle. When it comes to YOLO, we use convolutional neural network to predict the bounding box and probability of the category. Then we have these are the YOLO architecture and the process of the YOLO. Then this is our fundamental code. These are the training for KNN and SVM. We could get the accuracy and confusion of them respectively. We could see that the accuracy for the KNN is 94% and for SVM is 98%. That is relatively high. And this code are for the predicting. We input the video to this network or the classifier and get the result of them. These are the results for the first one is SVM, and second one is KNN, and the third is the YOLO. Is that the YOLO performance the best? It can clearly detect the car from non-car items in the whole video. The SVM performance not so good. It incorrectly identifies some non-car items as vehicles. The KNN performs the worst. It also computation and time consuming. Finally, we list some reasons could lead to this performance difference between SVM, KNN, and YOLO. And this is a reference for this report.